The next topic is unit vector. So as you can see the name, that is unit vector. So a vector whose magnitude is unity, that is 1, is called a unit vector. So definition of a unit vector would be a vector whose magnitude is unity is called unit vector. Now, what is the use of unit vector? It tells the direction of vector. Now, suppose there is a vector. Suppose there is a vector whose magnitude is not equal to 0. Okay, it is not equal to 0. That means more than 0. So a unit vector is defined as, it is written as a cap. This is the symbol of unit vector. A cap means unit vector of A, and its formula is given by a vector divided by magnitude of A. We will learn later on how you have to calculate magnitude of any vector. So for now, you can just learn that a cap is equal to a vector divided by magnitude of a vector. This is a symbol of magnitude. That is the value of that vector. And a cap means unit vector. This cap represent the symbol of a unit vector. As you know, there are 3 axes, x, y, z, which are mutually perpendicular to each other. So at each axis, we have unit vectors. That is the vectors which give direction. So we have one unit vector at x, one at I, and one at z. The unit vector at x is called I cap, at y it is called j cap, and at z it is called k cap. Now for example, if I say a vector is equal to 2 I cap, so I cap will tell you that this vector is in which direction? It is in x axis. If I say it is 2j cap, that would mean that vector is in y axis. But if I say it is 2k cap, that would mean the vector is in z axis. So these I, j, k tells you direction. Okay, and they are called as orthogonal unit vectors. The vectors along x axis, y axis, and z axis of a coordinate system are called orthogonal unit vectors. So these I, j, k are unit vectors, but they are called orthogonal unit vectors. If you want to give direction, if you want to give definition of orthogonal unit vector, you can write the vectors along the unit vectors along x axis, y axis, and z axis of a right-handed, or you can just write of a coordinate system, are called as orthogonal unit vectors. So suppose if there is a vector, which is given by 3I cap plus 2j cap. Now you have both the unit vectors, x also and y also. So that would mean that the vector is in xy plane. Okay, it is not at x axis, it is not in y axis, it is in xy plane. It is in xy plane. Now if I say there is one more vector, b vector, there is one more vector, b vector, which is equal to 3I plus 5k. Now I is for x, k is for z. So this plane would be xz. That means this plane. B vector is here, right? If you have I, j, k, all the unit vector in a vector, that means it is in 3D plane. That is in x, y, z plane. So by seeing the value of vector, you can tell the direction of vector with help of these unit vectors I, j, and k. The next topic is resolution of vectors, or you can say rectangular components. Now this is a very new topic for you all, and is very important for class 11 physics as well as class 12 physics, because we always resolve vectors while doing many derivations. So if you can see, this is a vector, and suppose it is moving in 2D plane. Let us say xy. Now it has certain components. If it is moving in 2D plane, like in last example, I showed that a vector is written as 3i plus 2j cap. So this 3i cap and this 2j cap are its components, right? The components of which it is made up of. I cap was for x and j cap was for y axis. So similarly, if you want to show those two components, so one component would be in x axis, let us say this, and one would be in y axis. These components are called, for example, if it is a vector, the component at x axis would be called ax, component in y axis would be called ay. Okay. Now how you resolve components? Suppose if vector is in this direction, this, and suppose this is b vector. How will you resolve? You just have to make with coordinate axis. Now you know there are 4 coordinate axes. How does the Cartesian plane looks like? It looks like this. We have x minus x, we have y, we have minus y. So if vector is in this direction, I'm talking about b vector, where would be x and y? This would be x and this would be y. So the resolving would be in this direction. This would be x part and this would be y part. This would be your theta. Theta is always made with x axis. So it would be bx and this would be by. Now suppose your vector is in this direction. Let this be c vector. Now where would be its two components? If c vector is here, two components would be this one and this one. This one and this one. So where would be your x? This would be your x axis. So it would be cx and this would be cy. Similarly, if you have one more vector whose direction is like this, where would be your two components? Till now you must have understood that where would be its two components. Its two components would be, one would be here, x axis, and y would be going downwards. So if it is d vector, it would be your dx and this would be your dy. Okay, this is how you resolve your vectors. Fine. Now, what is the value of ax and ay, or bx and by, cx, cy, dx, dy? The value remains same. The value remains same for x component and for y components. For x component, the value is ax is equal to a cos theta and ay is equal to a sin theta. This you can calculate by trigonometry also. If you make this a triangle and you apply value of let us say cos theta. Cos is base by hypotenuse. That is cos theta is ax divided by a. So ax is a cos theta. Similarly, if you apply sin theta, you will get value of ay to be a sin theta. Similarly, bx would be b cos theta, by would be b sin theta. So for y components we use sin theta, and for x components we use cos theta. So this is the way you resolve your vectors. This is important, and the value of components is this ax and ay.